Hey coders, welcome back. So this is our, I think, day 9 of daily assessment solving practice, right? So in my last video, I took this online assessment one, I think day 8, and we solved a question related to combination sum, and there was one more question which was related to in-place swapping based algorithm based question, right? So today I'm going to take this phone interview one, yeah, and let's try to solve it. Let's see how it goes. So it says like it can have 2 3 questions, and we need to solve it under like 90 minutes, right? You cannot pause the timer, so it basically helps us simulate the real assessment, real problem solving, right? So my motto of this videos is like I go through the questions, right? And even I don't know what questions are gonna come. So all my raw thinking, what are the things I know about the question and how would that help me to solve that question. So all things will be you will know, right? So yeah, let's start with today's assessment. This is day 9, and let's see how it goes. Okay, so we have a two question, right? So this is question number 1. Let's see what it says. So we have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Okay. Given an array of this containing zeros and one, where 0 means empty, 1 means not empty, an integer n, return true if n new flowers can be planted in the flower bed without violating the no adjacent flower rule and false otherwise. So it is okay, and I think I understood the question. So it says like you have this array, right? And the place where it is one, it means we already have a one flower there, right? And if it is a zero means empty, we can put one flower. So it says here, can we put one flower since n is equal to 1 anywhere in this array such that there is no adjacent ones? So this is the question basically. And so for example here, I cannot place flower here because it will these two will be adjacent, right? Can I place my flower here? Yes, I think I can because now here and here, right? We can make sure that a flower bed is empty, so it is not adjacent. So for n is equals to 2, it is not possible, right? Because the first flower can be placed here, right? And it is not adjacent to any. Now we don't have any flower at all, right? So I think I don't need any data structure or algorithm to solve such problem. I just need to iterate and make sure that all the adjacent elements are different, right? They are not one. So what's the idea? The idea is something like this. I can get the length of this flower bed, right? I'm calling it L, and then we have to place n flowers, right? So I'm gonna iterate from I is equals to 0, right? And if I equals to 0, then what we have to do? Else if um something like this, L if I equals to L minus 1, else, right? So if where I is equals to 0, so we just need to make sure there is a no flower on the right side, right? So in a greedy way, kind of like we wanted to place the flower as soon as we found an open spot. So I think that should work. Um, if I place here, yeah, I think that will work. We just need to find a place, and if we are able to put the flower, just put it, right? And reduce the n and keep check like whether n is equals to 0 or not. If it is a 0 or less than 0, then that means we are good. We can place that many flowers, right? So if I equals to 0, I cannot check backward, right? I minus 1, it will be minus 1. So we don't need to check. We just need to check at the right side. So, something like this. If a of I equals to 0, and then a of I plus 1 is less than L, and then a of I plus 1 equals to 0. This means we can place a flower at ai is equals to 0. So I can do n minus minus reduce one flower that is planted, and ai equals to um 1, right? It means basically we place the flower. So this is the condition for the very first. Then similarly we can check for the last. Very similar, like if a of I equals to 0, and I minus 1 is greater than equals to 0, and a of I minus 1 equals to 0. This means we can place the flower at the very last, right? So you can say something like this: a of I is equals to 1 and n minus minus. Now for other places, we need to check backward and the forward, right? So something like this. If a of I equals to 0, and I minus 1 is greater than equals to 0, and I plus 1 is less than L, and a of I minus 1 equals to 0, and a of I plus 1 equals to 0, right? So it is basically when we are in the middle, right? So we need to check there must be 0 in the right side, there must be 0 in the left side. So this is what I'm doing. And if it is the case, then I can say n minus minus and a of I is equals to 0. Sorry, a of I is equals to 1. So I think, yeah, these are the conditions we need, and then I can simply return n is greater than equals to 0, right? So our n should reduce to 0 if we are able to place all those required flowers. I think that's it, and nothing fancy here. Let me just check one more time. So this is the condition for the very first element. This is condition for the very last element, and this is the condition for any middle element, right? So if it is a middle, we can check just before it. We are not going out of bounds, so this condition will make sure. This condition will make sure, okay. And then a minus I minus 1 equals to 0, ai plus 1 equals to 0, so we can make. Yeah, I think this is it. Let me try running it, compiling it, see any compile time error. I'm not seeing any. Let's try submitting it. Okay, so we have one error. Let's see. Um, so it says true, expected is false, because okay, why we are getting this? So we come to here, we cannot place, and for here I minus 1 should be 0, I plus 1 equals to 0. Then we come to here, and then this will be n minus minus, and then we come to here, we cannot place because we already placed 1. And then, okay, why this is failing? Output is true, my output is getting true. um I don't know. Let's try simulating it one time. So this is for I equals to 0, right? Yeah, this is fine. This is for last element. So we don't need to go L plus 1. We don't need to check. And this is for the middle element. I equals A of I equals to 0, right? And I minus 1 is greater than equals to 0. I plus 1 is less than L. And AI minus equals to 0. And AI plus 1 equals to 0. And AI equals to 0. This means I can reduce n minus minus, and I can do ai equals to 1. This looks fine. And here ai equals to 0, and maybe I minus 1 is greater than equals to 0, and ai minus 1 equals to 0. So we can also place one element, and then we can reduce it, and similarly here also. This is interesting. Why this is happening? Am I missing anything? 0, 1, where 0 means empty, 1 means not empty, integer, and return to if n flowers can be planted in the flower bed. without violating the no adjacent flower rule or false otherwise. I mean, yeah, this is fine. Why we are not able to? Okay, let me do something like this. Let me try debugging in each of these conditions, see where we are going, right? So I can just say hello, and we are at index I, right? Similarly, let me copy this here also. Not here, here, and maybe here also. So okay. I have to copy the test cases. So let me copy this test case v and 2. Let's run it. Um, yeah, so here you see we are able to place element at 2, right? So 0, 1, 2, and that's fine. Oh, okay. Let me see. Yeah, for n is equals to 2. Okay, so our n should be 1. Oh, sorry. Yeah, this is the condition. So I'm taking n greater than equals to 0. This is bad. I have to take n less than equals to 0. Right, it's a small mistake. So when our we are able to place all the flowers, our n will be 0 or less than 0. Right. So yeah, let's try submitting it again. Okay, so I'm getting index of out of bound. Let me hide this test case and see. So here, um, yeah, because I have missed one condition. I plus 1 is less than L, right? So this is, we are accessing I plus 1, but we need to make sure we are not going out of bound, right? So yeah, let's try again. Um, okay, so these kinds of questions, there are multiple edge cases that we have to think. So here you see, it is filling for one flower bed, right? And yeah, so for one element, we need to make sure. So if L equals to 1, if A of I equals to 0, n minus minus, um, right, and then we can say return n is less than equals to 0. This is, I missed this condition. So for one element, right? So yeah, these kinds of questions, it is very, I mean, tricky. It's not tricky, but there are just multiple scenarios that we have to think of, and yeah, it's very easy to mess this up. Oh, my bad. This, what is this 0? It should be 0 now, not I. Okay, I think let me compile it one more time. Yeah, this is fine. Okay, so we are able to submit it. Yeah, I mean, you see, there is no any typical data structure or algorithm being used here. It's just like different case-based problem. So yeah, I messed up some conditions because there are so many, right? So yeah, but we are able to solve at least. So yeah, we are good. Let's move to the next question, right? Okay, so it says you are given a string S that consists of a lowercase English letters and a bracket. Reverse the string in each pair of matching parentheses, starting from the innermost one. Your result should not contain any bracket. Okay, so here you see this love will be reversed. So we go inside of this. So okay, let me copy this thing in my editor here. It says, sorry, so it says like you have to go inside of the bracket, and whatever value is there inside the bracket, you have to reverse it. So you see the very innermost bracket is this one, right? Love. So we have to reverse it. So our string will become something like this: U, then EVOLI, right? So this is after the first we reverse the string inside of this parenthesis. Now this is the now bigger parenthesis, so we need to reverse again. So it will be something like um ILOVEU, and this is what we are getting right in the output. So let's say constraint here. So constraint say like 2000. So 2 into 10 to the power 3, right? So we can solve n square solution will be acceptable. So what should be our idea? So parenthesis based problem, you see, first thing you should notice that it might be a stack based problem, right? So whether a parenthesis is valid or not, right? Prefix, postfix, infix notations kind of problem, right? So these kinds of problem can be solved using stack. Now it says like it is guaranteed that all the parentheses are balanced, so that's a good thing, right? So what can be the idea to solve this one? Um, so can we do something like this? So so for open parenthesis, we push item into the stack. For U, we're gonna push. For this, we're gonna push. Then for LOVE, we also gonna push. Now, whenever we see this closing bracket, right? So we need to pop these elements and push it again, right? So what's the idea? Let me show you. So let's say this is our stack, right? So empty parenthesis push, something like this. So this is my stack. Then you push, then empty again, push, right? And then L push, O push, B push, E push. And then when we see this closing parenthesis, now we're gonna pop out all those elements until we get this parenthesis, right? So till here, right? And then whatever characters we have popped, we need to push it again into the stack. So something like this. Now our stack will become, whenever we see the closing bracket, something like this. U, comma, E, VOL, right? And then we're gonna get I push, and then we're gonna again getting this empty closing parenthesis. So again we're gonna pop all these elements, right, and push back into the stack. So I hope this is clear. So if you haven't solved this kind of problem, I would highly recommend try to solve balanced parenthesis stack based problem. So it says something like, let's say you have something like this brackets, right, something like this, and how you can check like whether these parentheses are valid or not. So if you are able to solve that question, then again I would recommend to solve evaluating something like postfix based expression, right? Something there is one question how you wanna evaluate a postfix expression, and that will also help. So that will be a prerequisite for solving this question. So for now, since we understand, let's move to solving it in the code. So the very first thing I need a stack implementation. So let's choose that. I need a character. Okay, I have a spelling character, right? Stack. Linked list implementation I will use. Oops. And I'm using deck based stack because this is in Java, we do have a stack class, right? Something like this. But this is like a thread safe, right? So every method is basically synchronized and it has some performance over it. So if you are using a single thread-based application, right? It's not a concurrent. Use a deck because methods are not synchronized. And if you wanted to add the synchronized functionality, you can use the stack interface, right? Sorry, I think stack is a class. And that is also bad. That's why we also not use the stack because it's a concrete class. We always try to use abstraction, right? So maybe the implementation might be changed, but we're gonna use the interfaces. So that's a good, practice. Something called LISCO substitution, if you know. Right. So yeah. So we created the stack. Now I'm gonna iterate over each of my array uh, characters of a string, and then if ch equals to this, what we need to do, else if ch equals to closing bracket, what we need to do, and else. So this means this is a character, so I can simply say stack dot push ch, right? If there is an empty parenthesis, I can again say stack dot push ch. This is the easier case. Now what if there is a closing bracket? So we gonna create, maybe how we can do that. Um, Basically we need to pull all those elements from the stack and push it back. Maybe I can use a string builder temporary. P new string builder, right? And then while stack, and I know that the parentheses are valid. So for any closing parenthesis, there must be an empty parenthesis, right? So while stack dot p is not equals to opening bracket, I will say sp dot append stack dot pop, right? So basically extract all those elements and put it into my string builder. And after doing this, since now our peak will contain this, right, empty parenthesis, so I'm gonna do one more pop, right? And then I also need to append these characters back to the stack, right? So for example, for A, B, C, D, now our string builder contains like B, C, B, A. So I need to push those elements also. So for that, I can do over ch or C maybe SB the two char array. I don't know whether we can do this two char array in the string builder, but we will see, right? And we're gonna say something like stack dot push C, right? Yeah, this is the main operation. Now after all these things are done, let's create the answer from our string build. Maybe answer from the string stack, right? So um while stack dot size is not equals to 0, I can say answer dot append stack dot pop, right? So now we have something like this, and make sure to reverse it, reverse and convert it into string and return it as an answer. So I think pretty straightforward, nothing. But yeah, there is one thing you can learn from this problem, the stack-based problem. So let's try compiling it. See any compile time error. Okay, we have one error because there is a no to char array method in string builder, right? So I have to do to string first and then to char array. Let's see. Okay, yeah. So for this, we are getting DCBA. Let's try it for this one also, just to make sure we are correct. Um, yeah. Let me run it. Yeah. So I'm getting I love you, and this is what it is we are expecting. So what's the time complexity? Time complexity will be n square, right? In the worst case, we can duplicate. Otherwise, it obviously it depends more on the parenthesis. If we have only single parenthesis, will be like linear, right? So it totally depends on the parenthesis. But in the worst case, it can go to the n square. So let's try submitting it. Yeah. So yeah, we are able to solve all these two questions. Um. So I hope you like it. In the first question, we have nothing. This is very bad. I mean, I don't like these kind of questions. And yeah, this one is a good question. You can try to remember this one. It's stack-based problem, uh, very famous. So yeah, I hope you like it. Thank you so much for watching. Let's meet in the next video. Thank you.